the Sustainability Management Master's Program, you are answering one simple question. Do you care about your future generation? If you care about your kids, their grandkids, then you care about sustainability. And a sustainability manager is someone who has the tools to make people understand how they can contribute towards developing a sustainable world. We have both part-time and full-time students. Our curriculum is 30 hours. Instead of thesis, we have a research project course and a seminar course which provides them with the kind of research background they will need to be successful in their job. But at the same time, sustainability is not always everything about environment. It also relates to the business. They will take a sustainable business strategies course. They will take a project management course. Most of these courses are going to be taught by industry people, the people who are doing sustainability on a daily basis as a part of their job. Any organization that has a large number of employees and has a physical infrastructure, they will have to have a sustainability office. If you have the passion to develop and maintain a sustainable world, come to us and we will help you shape your passion into a career which will create an impact. Speaker today, Doug Glory. Doug is the Vice President of Environmental Services at STV. In this role, he oversees a team of environmental engineers, scientists, industrial hygienists, and geologists specializing in environmental compliance, hazardous material surveys, and due diligence assessments. Doug serves as a point of contact for various on-call services agreements with the MTA, NICHARD, DASNY, and NYCSCA, and he directly oversees staff for all assignments that involve contaminated building material surveys, industrial hygiene, Phase 1 ESAs, and Phase 2 ESIs, remedial investigations, and abatement design. Doug has a Bachelor of Agricultural and Biological Engineering from Cornell University and an MBA in Finance from Baruch College of the City University of New York. Today, Doug will talk about environmental regulatory compliance and sustainable construction process. Doug, all yours. Thank you.
Excellent. Well, thanks for that nice introduction. I appreciate it. And thank you all for having me tonight and letting me talk about my favorite subject, which is environmental issues and sustainability for the next hour or so. So like Professor mentioned, I've been doing this for approximately just over 30 years now and still doing environmental engineering on a daily basis. Started off in consulting, working for a small consulting company here in New York City, and doing the basic type of work that is commodity types of work in environmental industries such as asbestos and lead, and also doing some due diligence, and then getting more involved in sustainability, going back to when LEED first began in the it's been the late 90s, early 2000s when they first developed the system for LEED. So I was one of the first group to get LEED certification, and started doing projects soon thereafter, consulting buildings who wanted to become LEED certified, mostly in New York City, but I did one project in Boston to do indoor air quality. I think the important thing to know is that there's environmental regulations, which are the cornerstone, the bedrock of the environmental industry, which then it's the bare minimum. If there's a regulation, there's a law, that is the minimum that industries and companies have to comply with in order to comply with the law and not break the law. And then sustainability is a system on top of that, which is an accounting system, so to speak, a way to assign points and value to certain attributes such as energy efficiency, water usage, indoor air quality, sustainable sites, locations, and that point system is what we'll talk a little bit about today. And I'll start with, just going over, it's not moving ahead. Let me see here. Oh, there we go. Okay. Yeah, so the topic will be environmental regulatory compliance and construction processes, because once I started off as a consultant, I then worked for the state of New York for a couple of years, and that also gave me a different perspective of being a state employee, understanding that working for the owner, so to speak, the state-owned bridges and tunnels, everything from the Verrazano Narrows Bridge to the Brooklyn Battery Tunnel, Queens Midtown Tunnel, the Triborough Bridge, which has been renamed. So all those facilities were owned by the state, and I was representing them. And that was a little bit of a different perspective on, the importance and urgency and how things were taken care of. And then I got back into consulting. Having worked at STV for the past 13 years now, great company. We focus on the built infrastructure. So we build roads, we build bridges and tunnels, we build buildings, and we maintain them. We do a lot of projects to maintain them. There's an incredible amount of deferred maintenance that has been, a problem over the years, because there's not, the industry that we're getting into, you'll be getting into. Sometimes there's a very glamorous building, like a brand new building. It's shiny, it's brand new, it's got all the new bells and whistles. But a lot of it is maintaining the existing infrastructure. And that's a big challenge today, getting the funding, getting, doing the right thing, and not just doing the quickest thing, because it's very easy to take an existing building and demolish it and build a new one. It's much more difficult to do a sustainable project and to take that building and maybe do a gut rehab, take all the inner systems out, replace them with new ones, but leaving the structure there. That's the most sustainable thing that we can do as engineers, is reuse the existing infrastructure instead of tearing it down and starting from scratch again. But I wanted to start with a little bit of description of what is sustainability and what is not sustainability. There's a conversation right now in our company, in the industry, what is resilience versus sustainability. And resilience, we'll start with that, is it's resistance to potential hazards. And it's the ability to recover quickly after an event, such as a hurricane or a flood event. And resilience is the ability to minimize the social and economic impacts of those events. So for resiliency related to infrastructure is one thing. The other side of the coin is sustainability. And sustainability is basically protecting the environment from the infrastructure. So sustainability is ensuring that construction, operations, and life cycle have the minimal impact on the environment. And that's what we'll talk more about today, is that idea of sustainability, how we can, as engineers, design buildings to be environmentally friendly, have the least impact on the environment. So here you see STV does resilient design. We're dealing with a variety of different issues that we are designing for. Some are climate conditions, such as sea level rise, which is the most common one that a lot of talk about that now. Tidal inundation or drought. There's hydrological events. Flooding is the one that comes to mind recently this year. We've seen that throughout the world, massive floods, and even in New York City, we had recent flooding just a few weeks ago that impacts all of our lives. And then we had Sandy and Hurricane Irene and Ida. So there's been a lot of recent flooding and extreme events that we should be doing resilient design to protect against natural disasters, hurricanes, and you see much more fires recently. There's also failures and emergencies. We deal with this quite a lot. Environmental contamination is a very common topic that I will talk about. Back in the early days of, in the 1940s and 50s, when there was a industry manufacturing something, say paint or chemicals, a lot of times they would manufacture it in the plant, and that was the boundaries of their system. And then they would have a pipe that would drain the waste out of their system into a different system, which was a river, which impacts us all. And GE was guilty of this. They disposed, well, I can put in quotes, disposed of their waste, which was PCBs, polychlorinated biphenyls, which is a known carcinogen. They deposited that in the Hudson River. That's a great example of environmental contamination. And it wasn't their problem because it wasn't in their building. They didn't want to pay for disposal to do it the right way. So it was much cheaper and easier to dispose of it in the river. And now we're going back and making them clean it up. There's a huge lawsuit, and the EPA declared the Hudson River a Superfund site, and they were forced, GE was forced to pay for that cleanup. So that's a consequence now of what they did. And then, of course, there's terrorism. So resilient design is protecting our infrastructure, roads and bridges and tunnels and buildings against all of these different factors. And then sustainability and sustainable design is designing for these topics, designing for people to make sure that there's good indoor air quality, that we're not being exposed to any chemicals within our buildings or tunnels for that matter. Energy, are we building buildings that are better insulated so that we have to use less energy to heat them? Everything, and then also buying renewable energy. Energy auditing, very important factor. I did this a while back. I got into energy auditing, and we would use various tools to make sure or to quantify the amount of air exchanges that a building had every hour. So we would apply a negative pressure to a building by putting this big fan in the front door of a single family home, for example, draw the air out and measure the barometric pressure difference between the inside and outside, and figure out, we calculate the number of air changes per hour, and then you'd assign a number to that to figure out how efficient the building was and how airtight it was. So that's an example of energy wasted. So sustainability also deals with the climate and wetlands. I have a slide about that as far as how to protect wetlands, and that goes back to sustainable idea. Goes back to regulatory compliance, permitting, which is the foundation of this whole topic of sustainability. Talk a little bit about materials, using recycled materials, very important. I've got a great case study to describe tonight. And also locally sourced materials. It may seem like common sense, but when your client, your developer's in a rush, they want to buy something off the shelf, regardless of where it came from, regardless of the carbon footprint or how many miles that piece of material had to travel to get to your site. But if we take the time to think about it and we design things correctly, and our clients and building owners force the developers and contractors to do it, then it'll happen. And then water, we do a lot of work with stormwater management. Working on a project right now. It's a new bus depot in Jamaica, Queens, and it's before the New York City Transit Authority. And we are working on a stormwater permit. And as simple as it may seem, but there's a lot of calculations to figure out the perviousness of the site, how many acres. We're designing for retention and detention tanks, and figuring out how we can hold some of that storm water and then release it later so it doesn't overwhelm the stormwater system and then contribute to flooding. So all these things are some topics we'll talk about tonight. But I wanted to just give you a little background on the typical work that I do, that I'm familiar with, that is common in environmental consulting and sustainability industry. And I'll break it down into a few things. Environmental investigation design. This is considered due diligence. Anytime that someone wants to buy a building or build something, it's a good idea to have to have a look. What's the history of that site? What has been done there before? Are there any environmental considerations that we should be designing for? And that's a phase 1 and phase 2. Hazardous material management. This is your typical materials that were, miracle products when they were first developed: asbestos, lead, and PCBs. They were great at, what they were designed for, but they're also carcinogens, they're toxins, and they're dangerous when we're exposed to them. Environmental planning, this is permitting, this is making sure that the public is not exposed to excessive noise and vibration from construction, and its air quality, to make sure that our construction sites don't create bad air quality from dust, from diesel emissions, idling trucks, things like that. And transportation planning is part of that, because when we say we're building a new road somewhere, we want to also look at and consider the impact of what traffic will be created from that new facility. How many more cars will be on the road, how much more emissions will be created, and what other effects will our project have on the environment. Natural resources, a lot of permitting. There is also endangered species assessment. One example I give there is there's a brown bat in Pennsylvania, and there's a certain period of time when that brown bat is nesting, and you can't do any construction. I think it's in November and December. And you have to make your client aware that all work has to stop if you're affecting any trees or their habitat. And you have to be aware of that so you can schedule the project correctly, because the last thing a contractor wants to hear is that, okay, we have to stop work. That is the last thing. So, as the environmental professional engineer, you should know about that and be aware of it. And construction oversight, we do a lot of this type of work, including, we start with the environmental due diligence, and then we do survey and sampling, the inspection part. We do the air monitoring during construction, and then we oversee abatement of asbestos and lead, and that's considered construction oversight. So it's, full range of services throughout the project. Environmental services, here's a couple of our recent projects that we worked on. One of the most exciting ones that I worked on recently and in my career probably was Newark Terminal A. This is one that I live nearby, and every time I drive by, I'm always pointing and bragging about my contributions to the good indoor air quality of that building. And it's amazing. I don't know if anyone's flown out of there yet. I have not personally, but I know some people who said it's just a really, really nice building to fly out of.
It really is. I have been there a couple of times. Like I
Really?
cannot even believe that we have it in Newark.
Yeah, it's great. Yeah, really, really good for the region. Beautiful building, and I'm really proud of my company STV having worked on it, and together as a team we got it done. It's quite and on a very challenging site too. I'll go into more detail later, but the site is, as you can imagine, that airport was built in the 50s, before a lot of the environmental regulations were passed in 1970. So contamination was everywhere. Stormwater investigation, that's a interesting picture we did at a federal site in Virginia, and it was a firing range. So you can imagine there's a lot of spent lead in the soil, and that's that lead works its way up the food chain. The grass grows on it, grass pulls the lead up into it, and then deer eat it, so the deer become lead contaminated. Whenever it rains, the lead, the smaller particles get dragged away downstream, so fish get contaminated and poisoned. Salamanders, you can imagine everything in the surrounding area is affected by the firing range. So we did delineation of lead to figure out, how deep it went in the soil, how far out it went, how far downstream it went. Very interesting project there. And then we advised them on how to clean it up and dispose of it correctly. And then we do some work with underground storage tanks and remediation. So I think it's very interesting industry, and I'm still doing it, so it's must be something good. So we'll start off with the phase 1 environmental site assessment. This is the basic type of assignment that we get and we advise clients on. We do a lot of this work for the New York City School Construction Authority. Whenever they want to lease a new space, they ask us to go in and look for it. Contamination and environmental risk. And really, the way I see environmental issues are we're managing risk for our clients. And that goes all the way through everything, even sustainability. There's risk involved. There's risk of, there's always money involved. There's always time and schedule. And, if you promise your client you're going to get LEED Gold, well, then there's money and time associated with that you have to be careful of. But phase one is the classic environmental risk analysis. And this is a way to, for the landowner, the property owner to become, to not get sued under the CERCLA Act of 1980. And the purpose is to identify, recognize environmental conditions as they exist at the site at the time of the site visit. And, the purpose is to identify conditions that would have a potential to impact development and use of the site. Phase one, my favorite part, besides the site visit, I like getting out of the office and going to the site, looking at the properties and seeing what's there. But a lot of it is reviewing of historical data. We order a big database that includes Sanborn maps, which I'm showing on the screen. And we also order old phone book records of the site and topographic drawings, as well as aerial photographs. And if you like history at all, this is exciting because you get to look back, and they provide you with maps going back from the present back to the late 1800s. And New York City is full of interesting things. So this one I thought was a great example. 1951, this site was occupied by auto repair shops, ironworks, lacquer printing, and an auto wash. There's also a site that was a filling station, which had 6 gas tanks, another one with 3 gas tanks. Surrounding properties, more gas tanks. The interesting thing here is that before 1970, a property owner could, open up a gas station, and it didn't take much permitting. There was very limited oversight. There was no checks and balances. So you could just, building owner, buy a tank, hook it up to a pump, start selling gas. And those tanks were single wall tanks made of steel. And you can imagine, since 1951, they're exposed to moisture in the soil, they corrode, and they start leaking. So these tanks were unregistered. No one knew how many tanks there were really. I mean, this map shows 6 gas, tanks in one property, but they could have 6 more that were unregistered and undocumented. And that's what we find. Those are the surprises that really make it interesting when you dig up those extra gas tanks and have to stop work to clean them up and figure out how far the contamination went. And the other types of businesses, ironworks, you may have some contamination there. Could have been painted iron, so there could be some lead-based paint in the soil. There could be other contamination from metals, heavy metals of all sorts, also from welding materials and lacquer printing. There's some, a lot of chemicals involved there. There could be volatile organic compounds in the soil. So all these things, trigger this recognized environmental condition. And we would then say to the client, well, you have these conditions, you should, it would cost you this much money to clean them up. You should consider doing additional sampling as far as a phase 2. So once we've identified those recognized environmental conditions, also known as a REC, REC, then we would advise the client and make recommendations as far as what to do next. Typically, that would be a phase 2 environmental site investigation, which we're showing on the screen now. This is where we then do some sampling. So we hire the drill rig and an operator. We show them, where we want to collect the sample, and they drill down to whatever depth we think. If it's an underground storage tank, we might drill down to, beneath the invert, say 10 feet down. That's where the contamination would be. They pull up the sample, we collect those samples, send them to a lab, have them analyzed, and figure out what type of contamination is there. Is it a petroleum type contamination in the case of a gas tank? If it was a dry cleaner, you could have all sorts of chlorinated solvents. Those are pretty nasty, and those things, they don't break down. And also a lot of these contaminations, once they get down, work their way through the soil, then they wind up hitting the groundwater table. And the groundwater table, if it's pretty shallow, say 20 feet, once it hits the groundwater table, then it becomes dissolved in that groundwater, and it can go in any direction. And it can travel very far, creating a plume that could travel under an adjacent building or around a building, creating indoor air quality problems or contamination under an adjacent building. And that becomes very tricky to clean up. So the photo on the left side of the screen is the phase 2 investigation we did at a SEPTA site, a train yard in Pennsylvania. And there, why would we be doing it there? Well, a lot of times they have substations, and those substations contained electrical equipment, and that electrical equipment gets very hot over time. So a lot of those transformers, arc shields, they are encased in oil, which first of all is a danger if it becomes released to the environment. And a lot of times they also added PCBs to that oil, which helped cool it and disperse the heat so that the electrical equipment didn't get overheated. So here we're looking for that type of contamination. On the right side of the screen, this is a picture from New York City, Coney Island Yard. Same problem there. They used a lot of electrical equipment. And a lot of times, if you know your history, you'll know that, especially in the cities, a lot of the train yards and government facilities were built on old swamps, because swamps at the time were not considered valuable property. They didn't understand, what the services that the natural resources provide. That now we know swamps and marshes provide a habitat. They provide, they slow down wave action from storms. They provide a lot of services to the environmental and society. Anyway, they filled this yard in with industrial debris, in essence. And here we are sampling it, trying to find out what's in the water table. And this is the kind of setup that we use. Dig a hole, we put the temporary well in there, and we collect samples. So this is, we'll talk more about that later. I've got another slide on the details. And then after we've done the phase 2 and delineated the contamination, we figure out how far down it goes horizontally and vertically. Then we can figure out how to clean it up. And typically, the most common way to clean up soil contamination is to dig it up, put it in truck and dispose of it properly. But we have to know it's in each truck. We have to dispose of it using the appropriate transporters who are licensed and disposal facilities. So this is one of our sites in Queens, looking west towards the Chrysler building there. So this is a typical outcome of that project. So I'll get a little bit into the other types of work we do as an environmental engineer, environmental scientist, and that is considered part of the sustainability. Asbestos, it's a great material. It's naturally occurring. Believe it or not, there are outcroppings of asbestos in Staten Island. If you drive on the Staten Island Expressway and while you're sitting in traffic, you look to the left or right, you'll see a greenish type rock. That is serpentinite, which is asbestos. And it's also found underneath Manhattan. There's an outcropping there. And you may have heard other presenters talk about it as we built the 2nd Avenue subway and other seven line extension. They went through naturally occurring asbestos, and they had to take certain precautions for those tunnel boring machine operators. They had to wear personal protective equipment and take care of the spoils and dispose of it properly. So it was commonly mined. Believe it or not, it was commonly mined in the U.S. for years and years, and it was until recently mined in Canada. It is a great material too, because it was fire resistant. It was a great insulator, and it was used throughout the U.S. I thought this was interesting because you can see here, these are locations of asbestos occurrences in mines in our general area of New Jersey and New York up to Massachusetts and Connecticut. A lot of active outcroppings, and it does come up commonly. I did a project recently in New York City, and there was naturally occurring asbestos in Staten Island, and we had to deal with it. So it's something that you may come across in your careers, and you should just be aware of it. It does happen once in a while, and it's pretty simple to deal with. You know, you use engineering controls. In this case, the engineering control is simply using water to wet it down and keep the fibers down so that nobody's being exposed to them as a worker and as a neighbor in the community. A little bit of history here. You know, Canada, Brazil, mining a lot of it, 360 tons, pretty recently in 2015. And it's in a lot of materials. The interesting thing, as an engineer, I have to also educate my peers in my company. Everyone thinks that it was banned because, in fact, it was banned in 1973. The EPA realized, well, asbestos is a carcinogen. If you breathe too much of it in, you're going to get lung cancer. And you see those ads on TV, right, about mesothelioma. You got lawyers out there trying to have you call them so that they can make money. So that was because when they were exposed 30 years ago, there's a latency period, and now they're exposed, and it's becoming a problem now, 30 years later. Anyway, it was banned in 1973, but because of pressures, and then it was banned in all products in 1989. So everyone thought, well, that's the end of it, right? Not quite. So in 1991, industry, complained to Congress and EPA, and they said it's too difficult to manufacture products without asbestos. We can't manufacture, brake pads and gaskets. So EPA said, okay, we'll lift the ban for certain products, and these are the ones. Pipeline wrap, roofing is the most common one. Roof coatings, floor tiles, and gaskets. So just so you know, it's still being manufactured. It's still legal to make it in products. Here you see the old type on the left, asbestos, and you've got the newer types, fiberglass and foam. This is interesting. So we did a project at the called the Avenue School, and it's a brand new school on 10th Avenue in Manhattan. And we did a phase one, which I talked about earlier. It's environmental due diligence, and part of that is a site visit. And we ask questions. Are there any underground storage tanks, and are there any asbestos? They said no to both. There's no underground storage tank, no asbestos. And they said, well, there might be a tank right here, but it never leaked. It's fine. The boiler always worked. So once we opened it up, and we found that they had done an asbestos abatement project. They had removed asbestos from beams and other things. And then we found that there were bags and bags of it inside of the oil tank, which is, obviously very illegal for many reasons. They illegally disposed of the asbestos, probably contaminated the building. And then we had to, properly dispose of it. So this is the type of thing that you might encounter on your project. And this oil tank, by the way, the building owner claimed it never leaked, and his boiler always ran. Well, sure, some of the oil may have gone from the tank to the boiler, but a large amount of it leaked out of the tank underneath his building, underneath the sidewalk, underneath an adjacent building, creating all sorts of environmental issues. And we had to get the DEC involved. We managed cleanup of the contaminated soil within the building, and they allowed us to abandon the rest and leave it out there for the next person. Cleanup is pretty simple. If you're going to abate it, you have to set up a containment, especially for, in this case, it was fireproofing, which is incredibly friable, meaning it becomes airborne very quickly. This is an example of a containment where one of the things that an environmental engineer does as far as hazmat, we would calculate the airflows, and you have to have 4 air exchanges per hour inside the containment. So we would have to figure out size of the containment, length with height. This one had, in fact, you can see here, 8 air changes per hour. and then figure out the type of fan to use in order to get that minimum air changes per hour. In this case, we would need, if we're assuming that the negative air unit fan and filter is only 50% efficient, because the rating say is I don't know, 300 CFM, then once you put the filter in there and have the duct hooked up to containment and the loss of efficiency in those bends, then you're looking at a 50% efficiency of that fan. So if we use that calculation, we would need to pull 106 cubic feet per minute, and therefore we spec'd out a 110 CFM negative air unit for this particular case, to make sure that it was designed properly. So that's an example of a simple design that we do, something that you may be reviewing in your career someday. And here's a picture of some actual asbestos abatement work. This is at the Triborough Bridge, and here you see the expansion joints. Every time you go over the bridge, you hear that ka-thump, ka-thump, ka-thump. That's the expansion joints between each section of bridge. And in order to allow for bridges have to move because of wind, vibration, things like that. There's these expansion joints, which are flexible joints, and the best product for that was asbestos. So here you see them, removing it, wearing proper PPE, and the picture on the right, you can see the containment. So this is something that we would have designed. You have the plastic sheeting around the edges of the containment, and up there you would have a negative air machine pulling the air through, creating a negative pressure within the containment so that the workers are safe and not being exposed to asbestos. In addition to you can see they're wearing respirators here. They've got HEPA filters on their respirators, and that's providing a protection factor of 10, so that they can be exposed to up to 500 particles per hour. So that's the typical containment, typical type of work you would see. So the reason I bring this up is because asbestos is related to lead, and after you complete your design, your abatement, then you would take that documentation, you take your survey report, your design, your abatement documentation showing that asbestos was removed, air samples were taken. You submit that report to the U.S. Green Building Council, and that would be considered a point on the Sustainable Sites Credit 3 for brownfield redevelopment. So it's part of LEED, and this is what we did for this project. Was specifically for Newark Airport project. We did submit our documentations and got 1 point there. Lead containing materials, another once considered a great building material. It's had many great attributes. It was relatively cheap, relatively local. We mined it here, mostly in Colorado. You've probably heard of Leadville, Colorado, which is now considered a Superfund site. And once it's mined, it's easy to melt. It melts at a low temperature, meaning it can be easily formed into products, everything from fishing weights to, most commonly, lead pipes. I saw a very, very interesting movie over the weekend called Lead and Copper, and I highly recommend it to everyone to watch, because it talks about Flint, Michigan, and all the mistakes. So a lot of mistakes that were made by engineers, by government officials, Department of Environmental Quality, politicians, and just the whole 2 hours of lessons learned, what not to do, and the consequences. These people, they lied and they falsified data, and they basically exposed 100,000 people to lead in water, including children and babies. It was a horrible outcome. But good movie to watch, and I think very important movie to see. And they also talked about Newark. Yeah, they talked about Newark, New Jersey. Similar problem. In fact, the important thing is lead in pipes is common throughout the entire country, because it was, like I said, it was manufactured up until probably the 50s or 60s. It was cheap, ubiquitous, and it was the material of choice to connect the main water line from the street to your building. And what happens is when the water gets in there, it sits overnight, it leaches the lead, and then when you turn on the faucet in the morning, the first plug of water you get is the highest concentration. So if you live in an older building, it's wise to flush that first draw for a minute or so before you brush your teeth. But Newark, same exact problem. They self-reported, they went to the EPA and said, hey, we have a problem here. We discovered that we have high levels of lead. We need to fix it. The EPA stepped in and helped manage it. They kind of took over the project, but Newark replaced, I think, something like 95% of their lead service lines in a matter of 4 years. And they are, I would consider them how to do it right. The movie didn't portray it that way. But I would say from an engineering standpoint, you have to balance out, you have to have money for all these projects. It's not, you can't just wish these projects to happen. And it costs a lot of money. I think each service line was something like, they said $5,000 for a 20-foot section of pipe to be dug up. You got to pay for the labor, you got to pay for disposal of soil, all these things. Anyway, back to the slide. This one is again at a New York City transit property. They had filled in that swamp and the marshland with, construction type soil, which happened to be loaded with lead. So this area was very high concentrations of lead. So we considered it a project that had to be remediated. So the workers are all wearing their PPE. They're wearing half-mask air purifying respirators. And this was set up a textbook situation. So you have here the hatched area was the exclusion zone. So this is the area that was hot. It was high levels of lead. And the work area, the scope of work was pretty simple. Scope of work was to install a new fence around this ball field. And the fence would have went down the middle of this hatched area. So, we took samples and, it was definitely high levels of lead. Exclusion zone there. And then you had a decontamination area. Workers would come out. They would, wash their hands, make sure they were clean, take off their Tyvek, dispose of them properly. And then the support zone was where you would store the waste. During this work, and here it's good, because beyond the yellow was the exclusion zone. Between the yellow and the red was the decon area. So it's not every day that you have a project that's set up textbook, perfect. But this one I feel was a very good example of how to do a project the correct way. And then we did air sampling, because when the contractor was digging up the foundations for the foundations, they were stirring up a lot of dust. We wanted to make sure that the workers and the public, just beyond this fence, we wanted to make sure that kids walking to school were not breathing in lead dust. We didn't want to add to the problem. We collected samples. This here is a small pump drawing in air at between 1 and 4 liters per minute, which is the rate at which we breathe. And then it's hard to see, but there's a small filter attached to it. So the pump draws the air across that filter. We send it to a lab. They analyze it for TSP, which is total suspended particulate. We measured that in micrograms per cubic meter. And then we had 3 other stations which were monitoring for lead only, again, micrograms per cubic meter. So let's see, the lead, very low, below detection of 3.2, which again is below the OSHA action level of 30 micrograms per cubic meter over an 8-hour period of time. And TSP, I can't recall offhand, I think it's 150 micrograms per cubic meter, I think, for total suspended particulate. So this one done well. It was no significant amount of lead or particulates in the air. Other examples, there's a lot of lead in paint, and we do consulting and advising to property owners in the city. So here you see a few examples of that, how it's being managed. This, this one's a good example, abatement of lead-containing paint. You see all the plastic sheeting here. They're probably removing it from the wall or something like that. again, you see more lead sheening to delineate the work area from other non-work areas. But this is, a lot of labor to remove all that lead paint from buildings. So let's keep going here. Mold contamination. This I would consider part of indoor air quality. A lot of old aging buildings have various problems that create mold. Mold needs several things in order to live. It needs a substrate on which to eat off of. Basically, mold is a living organism that needs carbon to thrive on. So it lives on paper backing of sheetrock, ceiling tiles, anything, glue on the back of drywall and wallpaper. And here you see one of our team members taking moisture meter readings to determine if it's still the leak is still active. But this would contribute to indoor air quality if it were a problem in the building. Soil vapor. This is we talked a little bit about it earlier. Industry could off gas or dry cleaners are notorious for leaking chlorinated compounds into the soil, which get into the water. And then these compounds are common. Tetrachloroethylene, known as PCE, trichloroethylene, benzene, toluene, ethylbenzene, and xylenes, BTEX, as we call them for short, and methane. So again, we're back to Newark, Terminal A, favorite project. This project here, design build, we've worked on it for 6 years, recently finished, obviously. Our goal was to, we promised the client that we would get silver when the team, but we actually went above and beyond and were able to attain a gold, which is a higher level. My colleague, Peter Berger, is an amazing engineer. He managed this whole process as far as LEED certification to attain that. And the consultant credo is under promise and over deliver. And this was a good example of that. So remember that if you remember anything, under promise and over deliver. So here we'll talk about a few of those credits as far as LEED goes. This first one, here you see a rendering, a drawing of the facade, the west facade of Newark Airport. And over on the right-hand side, the annual incident solar radiation levels. The idea is that we want to design the windows and the insulation such that we have to reduce the heating and cooling load within the building. So if we can provide very high insulation on windows and walls, well, then we can spend less energy heating and cooling the building itself. That's very important. It seems very simple, but it's important to know. We want to reflect sunlight in the summertime, and we want to be able to absorb it in the wintertime. So our colleagues did an energy model to predict the energy use, and we compared that design to a standard building design. And then that's how you get points for LEED, is by comparing your design to a standard building design, and we're able to get points. And if you can increase the energy performance of your building, you get more points. So it's a balancing act here again. As an engineer, you want to get the highest, the most energy efficient building, but at what cost? Your client, in this case, Port Authority, using taxpayer dollars, has a limited amount of money they want to spend. So, how much do we want to spend, and on what points? Because not all LEED points are the same. Some cost more than others. So, it takes the whole team of engineers to figure this out. And for this one, we most likely relied on the mechanical engineers who do the energy modeling. We asked them to figure out heat loads and cooling loads and what type of energy is required to run the HVAC to attain that. Now, my area of expertise, I'm more of a indoor air quality and hazardous waste materials engineer, and I deal with asbestos and lead more. So it takes a team to figure this out. Anyway, I thought that was an interesting example of the type of LEED points that we attained on Newark Airport. This is another one this is the heat island effect. And you see a photo drawing here of the airport. And it's color coding over on the right-hand side, showing the solar reflectivity and the reflectance index of each part of the building. It's important to design the building with low. We want high solar reflectance, so we want the sunlight to bounce off the top of the building, so it's not absorbing a lot of heat. We want to use materials that have a high solar reflectance. In the bar chart, the lighter the color on the bar chart here has the higher solar reflectance. Again, trying to get the most points possible at the lowest cost, and designing that within budget. And also, of course, combining that with the architect's concept of there's always a struggle you'll find between the wishful thinking and the beautiful design of this building, and then the reality of what we have to implement as engineers and how to attain that. It's a constant struggle and conversation on what's the best way to do it. Luckily, there's a lot of brilliant engineers out there who can mostly make it happen. Another one, this is post-construction indoor air quality testing. So this is something that I have done in the past. So we set up this particular case. You can see another simple drawing showing the 4 red dots are an example of where we had 4 air monitoring stations. And the reason we have to have these 4 individuals was they had to be aligned with the 4 separate HVAC systems. So we had to make sure that each system was operating properly. Each one was providing good indoor air quality in this building. In total, we took approximately 45 air samples throughout the terminal, and this always happens at the very end of the project, and it's always a lot of pressure on the air quality engineers to get it done quickly.
Doug,
yes.
5 more minutes.
Okay, 5 minutes. Okay. So here's again, it's a balancing act between meeting the lead points, getting it done quickly. Just an example, because of the fast turnaround time, these 45 samples cost about $50,000 to get done. We managed to do it. We got the lead points, but it's very expensive because of the fast turnaround. Okay, a couple more. There was also methane at this site. So we had to collect subsurface samples to figure out where the methane was located. And then our team designed a subsurface depressurization system. So here you see us taking the samples. There's a small canister here. This is a SUMA canister, and it comes to us from the lab, and it's under negative pressure. So the lab draws all the air out. Then when we get it to the field, we drill a small well into the ground, stick the tubing down there, and we open up the valve and suck the air into this canister, send it back to the lab. That's how we measure methane in existing soil, in situ sampling. Here you see, then we had to set up piping underneath the building in order to vent the methane out of the building. And we vent it out and exhaust it above the building out into the air. Here's some design of that system. Another design close up. Here's construction phase, our engineer inspecting the PVC piping to make sure it's all set up. And the difficult part is making sure it doesn't conflict with every other system. So luckily, I'm sure you're learning about BIM and modeling, and that's very, very important so that those pipes can go in. I was lucky enough to do one of the inspections, the testing of it to make sure it was pressurized properly. Here's a few photos of the final product. And this is something that, as an engineer, you might be doing the field pressure test report to sign off saying that, yes, we saw it, we turned the valves, we made sure that the appropriate pressure was being used. This one, stream protection, I explained before, we want to make sure that we protect our streams. This is how it's done. We basically design for protection, make sure that the construction debris is not, going downstream. We explained Marconi Island Yard earlier. lastly, I'll wrap it up with green buildings. The Green School Guide is similar. So there's a lot of different sustainability systems out there. You have LEED, you have Envision. Green School Guide is another one that we use. Here we're sort of accountants in this case. We're managing, figuring out what type of stone is used, what type of rebar, how much of it, what it costs, and we're accounting for all that. And at the end of the day, reporting it to the SCA and the Green School Guide to get points to ensure that the building is sustainable for recycled content, which is one of the different metrics. Regional materials, I explained that a little bit earlier. It's easy to get materials from anywhere, but a lot of times they come from overseas. You want to, Italian marble comes to mind, easy to get, but could you replace that with something that's locally sourced? And here another one you've probably heard of, certified wood products. These are products that the forest is managed, it's not clear cut. They use selective cutting, they maintain the forest, they replant, they make sure there's no soil erosion. That's the type of wood product that we should be using and we should be designing for. I think that's it. Did I make it in time?
Yep.
Okay.
Almost.
Almost. Whew. All right, close.
But that was